So I'm recording, so nothing bad to be said. Let's see. I'd like today to go over any things that you'll see that are coming up on the test that you'll have either tomorrow or Wednesday, depending upon the cohort. My plan is there's going to be a 2-part test. There's going to be 3 questions that you get to do as a group, and I'm going to go over very similar types of problems. And I want you to know that, yes, you can use your notes on that. So, anything you jot down today or previously, you can use. And then there are 4 problems that are on the on your own portion, in which you'll be able to take back to your desk what you'd worked on as a group. Socially distanced, of course. And then, so it shouldn't be too bad. And then we finally, starting on Tuesday, we're going to actually start the meat and potatoes of this class, which is good. So am I sounding okay? I turned my camera off because I get sick of looking at my picture. I'm sorry. Like, look at the dork in the green shirt. That'd be you, Stirrup. So I'm going to share my screen on my tablet. Did that screen show up, my friends?
Yeah.
Okay. All right. So please feel free to jot anything down. And then if there's time, we can go over any questions. But you will see a question like this. This will say, hey, we want to know what the slant or the end behavior, same thing, asymptote would be. That's an H. That's not, I don't know what that is, but slant or end behavior. And this is how you know that you were going to deal with a slant or an end behavior. When the numerator, the top part, has a higher exponent than the bottom part. So let's say we have, 2x to the 5th plus 2x to the 4th plus 3x to the 3rd plus 2x plus 5. And then we divide that by, let's say we're going to divide it by, x to the 3rd plus x squared plus x plus 1. Okay, so you know it's going to be end behavior because my highest exponent on bottom is a 3, my highest exponent on top is a 5. That automatically says end behavior asymptote. Yes, there are characteristics that you would have horizontal in this case, but not in this class, not on purpose. Okay, so what you want to do in this case is you want to do long division. And I made this problem a little bit more meat and potatoes than the problem that you'll have on the test, but similar idea. Okay, so I'm going to take my bottom and take this. And this is going to be a longer problem, so make sure you have some space. If not, I'll save these notes and I'll keep the video going. So you have that divided by whatever is on top. Now I'm going to put something in here. You tell me what I just did. And why did I do it? 2x, that should be a squared. What did I put in there that wasn't originally?
You put it in a 0x squared.
Yeah, so you want to make note that, put a space holder in there. Okay, now I'm going to move this all down a little bit. Cool. All right. So very first thing we're going to do is notice I have 1, 2, 3, 4 terms. So I'm going to count over 1, 2, 3. I'm going to start dividing right here. That okay? And all we do is we look at the furthest left. We'd say to ourselves, okay, let's pick a color. I want to find a fantastic color to use. I like this pink. I think it's a pretty color. So what am I going to multiply that x to the third by to make that the same as 2x to the fifth? What do you think? I would say definitely a 2. What does my x value have to be? What do I have to multiply x to the third by to get it to x to the fifth? No one's speaking. So I would say it has to be to the second power because 2x to the second times x to the third is going to be x to the fifth. So that's going to give me 2x to the fifth. And then plus 2x squared times x squared is going to give me 2x to the fourth. And 2x squared times 2x is going to give me 2x to the third. 2x squared times 1 is 2x squared. I want to subtract these. So note, I'm going to go 2x to the fifth minus 2x to the fifth. Those cancel. 2x to the fourth minus 2x to the fourth. Those also cancel. That made it nice. And then 3x to the third minus 2x to the third is going to give me just x to the third. 0 x squared minus 2x squared is going to give me minus 2x squared. And then I'm going to bring down my next two terms. And the reason it's two terms I'm bringing down is because I'm dividing by 4 terms. So I want to make sure I have 4 terms down here. Does the math I just did make sense?
Yes.
Cool. All right. So then my next step is what do I have to multiply times x squared to make that x, or what do I have to multiply x to the third by to make it x to the third? Well, it's already that, so I'm just going to multiply by 1. So 1 times x to the third is x to the third. 1 times x squared is 1x squared. 1 times x is 1x. And 1 times 1 is 1. And I'm going to move this down a little bit. So I'm going to go ahead and subtract these. If I subtract these, x to the third minus x to the third, they're gone. Negative 2x squared minus x squared is minus 3x squared. 2x minus 1x is 1x. And 1 minus 1, those cancel out. Okay, so this is just our remainder down here. So this here, this 2x squared, this is my end behavior asymptote, which basically means this is a parabola. So if I had graphed this, it's going to kind of look like this. So as I go extremely far to the right or I go extremely far to the left, those lines, as they continue to grow both towards infinity, will dictate what our end behavior asymptote would be. If I were to give you this as a group, could you figure this out as a group, my friends? Very similar type of problem, but not exactly the same, but very similar.
Yes.
Sounds good? All right. So that's first problem. Can I move on?
Yeah.
Okay.
Yeah.
Cool. Our next problem that you'll see on the group portion is we want you to find all the vertical asymptotes. Okay. Vertical asymptotes, if you remember, that's where the denominator is equal to 0. So we might give you a problem that might be something like this. Okay, so the vertical asymptotes are going to take place where the denominator is equal to 0. So where this is equal to 0. Okay, so what you can do with it is you just go x squared minus 25 equals 0. Add 25 to both sides. And where students get hung up on this is please don't forget the plus or minus. Let's get x equals plus or minus 5. So x equals 5 and x equals negative 5 are both vertical lines. Those would be the vertical asymptotes of our question. And that's all you would have to do there. Seem pretty simple? The one on the test is going to be very similar to that. So if you're able to do this with your notes, then you should be able to get those points there. Feel good? Can I move on?
Yep.
Okay.
Yeah, that's good.
And then the last one is we want the rules for horizontal asymptote with an example of each. Okay, so there's two main rules that take place for a horizontal asymptote. Rule number one is if the degree on top is less than the degree on bottom, you get y equals 0. So right on the x-axis. An example of that would be if I had x squared plus 2x plus 3 over 3x to the 5th plus 2x plus 7. Okay, because the degree on top is less than the degree on bottom, this creates a horizontal asymptote, which is this. That's the first rule. So could you come up with a different problem similar to that, do you think, on your own?
Yeah.
I'd say, yeah, make that exact problem, except change all the signs. Make all the signs negative. And then you give me a totally different example. It's like, really, that's it? Yeah, that's it. The second case is when the degree on top is equal to the degree on bottom. And so what that looks like would be like, let's say we had 5x to the third plus 2x plus 7 over, let's go 13x to the third plus 5x plus 8. What we're going to do here is we're just going to say y equals whatever my highest exponent, being those are the same, whatever the highest exponent is, so we're going to get like 5/13. So a line just above the x-axis. So the degree on top and degree on bottom is the line y equal a over b, where a and b, this is a and this is b. Okay, the rest of the problem doesn't make any difference as far as the horizontal asymptote. The third case that could take place with these would be the degree on top is greater than degree on bottom. And if that takes place, that means you don't have a horizontal asymptote, but you have an end behavior asymptote. Okay, and we already talked about that with our very first slide. So friends, if you were to work on this together, having your notes available to you, do you feel you can adequately do those three problems pretty well?
Probably.
I hope so. I hope so. The collective mind is always pretty good. Sometimes the collective mind, there might be the one person who's very confident about what they're saying, but they're completely wrong. So if you ever want to mess with people, say what you're going to say with confidence, and then they're like, they must be right because they're confident. So, all right, are we ready to move on to the sit at your desk, do this on your own portion? Okay, this is going to be on your own. So you might see a problem like this. It'll say write answer in interval notation. Okay, so let's say we probably give you a problem like this. And we want to know where this is less than 0. Okay, the less than 0 means below the x-axis. So your y values are negative. Okay, so I'm not quite sure what this graph would look like. I would probably jump onto Desmos with this. So I'm going to stop sharing here. And again, you got to use the Desmos for you. Let me just pull Desmos up on my computer. Cameron, did you get back in? Cameron? All right, let me send Cameron a quick email. He said his computer got frozen. There's my. I can't get in. Okay. So I'm going to take a look at my graph that I had. So I have in parentheses x plus 6 divided by, and the reason I'm doing that is so I can put the whole denominator underneath. Oh, it's not capital.
Mr. Stirrup, it might just be me, but I can't see your screen.
Oh, I bet you it is not you. I bet you it is totally me. I bet you I forgot to share. I'm sorry. Share screen. Desmos.
Okay, now I can see it. Thank you.
That showed up better? Cool. So make sure you have that in parentheses. So you have x squared. Oops. Down here. X squared plus 7x plus 12. And so, and then you want to do this, and I think Desmos is going to do it. You're going to use your less than sign to show the shift of 0. Okay, so where is this less than 0? Now, it kind of showed a little wacky because it showed up above, but where I want you to see is this point here. Come on, baby, do it. Oh, it's not letting me see it. That's -6, that's -4, and that's -3. So -6, I'm writing this down, -6, and then -4, -3. Okay. I'm going to stop sharing this. I'm going to start sharing this. So that showed up. So that means that if you had looked at your Desmos graph, where does this happen that way? It happens from -infinity to -6, both rounded brackets because we're not including it. We don't have an equal sign. And then from -4 to -3. So this is where my region on my graph would be below the x-axis. Did that show up on your screen okay?
Yes.
Yeah, it does.
Sweet. Next problem takes us back to Algebra 1. Okay, so we're going to use point slope to solve the linear equation when I give you 2 points. So let's say I give you 5, 10, and -3, 7. So first thing you want to do is you want to find the slope. So label this x1, y1, x2, y2. And let's find the slope. So the slope is going to be 7 minus 10 and -3 minus 5. So that's going to give me -3 over -8. So I get a slope of +3 over 8. Agree? And then we have to remember our point slope. Our point slope is this. So if I used this as my x1, y1, my answer is going to be y minus 10 equals 3 over 8, x minus 5. If I used this other one, if I use this one as my x1, y1, I'm going to get y minus 7 equals 3 over 8, x plus 3. Which answer do I want? You pick. They're both correct. Okay. That help you with algebra 1? Everyone happy?
Yep.
Yeah, buddy. All right. So let's see what else we got. This next one, we want to find the vertical and the horizontal asymptote. So you might be given a problem like this. You might be given a problem like this, okay? So first thing I want to do is maybe find the horizontal. So remember, there's two rules. If the top is greater than the bottom as far as the degree goes, then we don't have. If the top is less than the bottom, then we have y equals 0. And if the top is equal to the bottom, we get y equals a over b. So which of these scenarios do we take place with? 1, 2, or 3? Which one which falls into that category? And remember, we're looking at the highest exponent here and here. 1, 2, or 3, my friends?
3.
3 is right. So my horizontal asymptote is going to be, I have a 1 out in front of here, is going to be y equals 1/5. So that's a horizontal line. If the degree on top would have been bigger or been smaller than the degree on bottom, then we'd have y equals 0, which we don't have. And if our degree on top was bigger than the degree on bottom, we wouldn't have one. So you kind of have to decipher knowing those rules. And then the vertical asymptote, we're going to take the bottom and set it equal to 0. Muse, what do you got?
What does number 3 say? The y equals what over b?
A over B. A over B.
Yes, sir. Thank you.
Yeah, sorry, but I make my A's that way, and I blame my friend Chris Arviso because I saw him made A's that way in high school when we were freshmen. And so I started making mine that way too. So blame Chris Arviso. He's also a math teacher. I'm not sure how he's a math teacher. He wasn't the brightest cat, but he does teach in Arizona. All right, so if I take the square root of both of those, I'm going to get plus or minus. So my vertical asymptote is at plus root 2, and x equals negative root 2. So I have two vertical asymptotes for this particular problem. I don't need you to graph them. I just need you to say it. And then the last problem is going to be a total gimme. Make a problem that would have the slant or the end behavior asymptote. Okay, so that just means that the degree on top is bigger than the degree on bottom. And then you could fill it all in with whatever you want. So that is an example problem that would have a slant end behavior asymptote. The reason you know that is because the highest degree on top is bigger than the highest degree on bottom. So my friends, you have a total of 7 problems. You have 3 problems that you would have to see, or you'd have to do as a class, socially distanced, of course. And then once that's done, you can bring that sheet of paper back as well as your notes to your own desk and get the second part. And you're allowed to use my Chromebooks if you want to use Desmos, or if you have your phone, as long as your phone has Desmos on it only, and you're not having photo math show up, I think that's totally appropriate as well. Who say you got your hand up again?
Oh, it might have been leftover, but I still have a question. Can
No.
you go back to the last 2 slides?
So 1, not that one.
That one, and then the one before that as well.
Okay, so I'll stop there for a sec, and then you tell me when you're ready for me to go back.
Sure.
Yeah, baby.
I'm ready for the next one.
Okay, going back.
All right, I'm all good. Thank you.
Good to go? Perfect. All right. So any questions on any of this review that I need to go over any more depth for you, my friends? All right, so just so you know, I'm going to stop this share here. I'm actually going to leave on this one. All right, and there it goes. Okay, share this screen with you. All right, so, oh, wrong class. We are in Business Calc. And we're all the way to week 6. I only have up to week 5, so I need to add week 6. If any of you need to make up any assignments under week 5, there's the videos for week 5, the notes as well, and then either of the pages. The Thursday and Friday, we did in class, and so we went over that. So everyone's grade should be appropriate at this point. And I'll be right back. I can't remember what time we get out of class. I'm sorry. I'll be right back. Don't go hide without me counting. Okay, we got about 14 minutes left. I'm going to remind you, I'm going to go back to my screen and you're going to see me put this in. So I'm going to add week 6. And it is February 8 through 12. So in the February 6th, or the week 6, this week, I will put the video for this. It's empty right now, as well as the notes. And then I will put the what the assignment will be on for Wednesday or Tuesday or Wednesday. I actually won't have one in there. I'll put the Friday stuff in there. And then I'll also put, I'll do a week 7 and I'll put the Monday stuff in there, but I'll get that in probably about 25, 30 minutes. So that's what I got for all of you. Any questions for me? So I have a question, and please be honest with me because you know you're not going to offend me. Am I going too fast? Am I going about right? Do I need to slow down? Where should I be, my friends? Again, this is your education, so I want to make this as good as possible. Oh, I remember what we're going to do on Wednesday, Friday. We would not have a lesson. Well, we'll have a lesson, but it won't be out of our book because I was going to talk to you about some of the probability of certain games that take place as far as gaming goes. I was going to talk to you about how like sports books work and how they make their money. And so just kind of give you a overall picture into that. So any other questions for me, comments, ideas? No one spoke on how, if I was going too fast, too slow, just about right.
You're going perfect pace,
Oh, thanks, Molly.
I agree.
at least for me.
Okay, good. Yeah, I went back.
Crucify me if you disagree, but I think you could speed up a little.
Yeah, Jacob. I'll probably stay at about the same pace, but I appreciate the input. I'm just trying to. I went back. I was taking a look at all of your grades, and I'd say the majority of you are doing about 8 to 15% better in this class right now than you had done in last year, not last semester, but last school year's math classes, which I think that's pretty cool. And I kind of told y'all this is going to be a really hard class to fail. So no one should fail it. But I'm actually going to stop my recording.